Hey, what's up guys, this is Krishna here. Welcome to this exciting project walkthrough of Houdini Redshift Embryonic eggs. I submitted this project for Side Effects Houdini Challenge Day 11 Fluids. The project file is available on gumroad.com. Please support me by purchasing the file. I'd really appreciate it. Thank you. Let's get right into it. Okay, so I have a few containers here. One is the geometry container, and then the rest of them are all render containers, and a camera, a light, and then I have the Redshift ROP and materials, which we will talk about later. Okay, so everything really happens within this geometry container. Okay, please note that I'm at frame number 160 because I cached just that frame. Okay, but we will run through the simulation during this walkthrough. Okay, so I have 4 setups here, which represents 4 sources. Okay, so the first one is the balloon, the second one is embryo, third one is fluid 1, and the fourth is fluid 2. So let me go through them one by one. So I've got a balloon setup here, which is just a sphere. Okay, and I have this uniform scale, which I'll explain shortly. And then I'm remeshing it because Vellum likes remeshed geometries. And then I'm creating a group called main balloon, which I will use later on down here, okay, in the delete. And then creating a vellum cloth, which is standard except for the stiffness is slightly different. And then vellum pressure, which is also standard except for the stiffness. If you type in vellum balloon, you'll basically get these 2 nodes, okay, which are these 2. Okay, so I'm calling it geo ball and constraints ball. Okay, so let's move on to the second setup, which is the embryo setup. So I'm creating a line, just a line in the y-axis, okay, with length of 1 and points 50, resampling it, and this time I'm using the curve U attribute. Okay, curve U attribute is something that goes from 0 to 1. It goes to the full length of the line itself. So if you color it, let me just put in a color here. Okay, and I'll say point ramp from attribute, and I'm going to use curve U. You see here, it's dark down here and white up the top. Okay, that's all that is. Okay, and I'm using that to create this width attribute with a channel ramp function and using at curve U because you need an attribute here which is normalized. So if you don't have that, the ch ramp function will not work. And once you type this in, you click on this little icon here, you'll get this ramp here, okay, which you can adjust. Okay, so but you're not seeing anything here yet because I'm using it on the poly wire, and then you'll see it. Okay, and the wire radius is at width, which is the parameter I generated here. Okay, of course, you know, every time you adjust something here, you can see it changes. All right, so and then I'm poly beveling just this top part here, and on the right hand side I'm creating a sphere elongated in the y direction and then remeshing it and booleaning it together. I'm trying to create an embryo sort of thing. Okay, we'll get there. So I'm basically unioning these 2, okay, and subdividing that and blurring the point attribute and then bending it. There you go. I think that looks pretty good. And that's a negative 360 degree in the z-axis. Okay, nothing else changed. And then I'm remeshing that and using the match size. But these numbers and these things are references to the original sphere. So if I template that, you can see the embryo resides right in the middle of the sphere. Okay, and this is basically used as reference everywhere else on the right hand side, okay, for the other setups. And I'm calling it embryo, a primitive group. And then when you type in vellum struts, you'll get these 2, cloth and vellum struts. It's basically that. Okay, so in the vellum cloth, nothing else I changed here, I believe, except the stiffness. It's e to the power of 10, I think, by default. Oh no, it is the same. No change here. The struts, again, pretty much the same except the stiffness here. Okay, this is definitely much stiffer than the default, because the default is 10. All right, everything else is the same. So I called it geo EMB and constraint EMB, okay, embryo. And then we move on to the fluid 1 setup, where it's a sphere again, but slightly smaller than the main sphere. Okay, again, you can see the references here. It's 95% of the original sphere. And then I'm clipping in 3 directions, and then I'm switching them based on the frame number. And that represents this here. If I drive into the Vellum solver, oh no, don't do that. But dive into the Vellum solver, so I have this activation set to if the frame is greater than 1 and modulus of 12, which means every time the frame number hits 12, activation changes to 1, okay? And even though it's set to each frame, this activation needs to be 1 for each frame to work. So every 12th frame, this activation turns to 1, which then creates a new Vellum geometry, okay? And every time it creates a new geometry, both this sphere, which has a different uniform scale every frame, as well as this switch changes, okay? So every time the Vellum solver pulls in a new geometry, it'll be different to the previous one. That's the idea behind it. So if I look at that and push this, as you can see, it changes the sides and the size, okay? So it's all going in line with each other, which is good. And then I'm using a polyfill, okay, and then remeshing it and grouping it, called out of fluid shell, which I don't know why I created that, but anyway, it's there. And then I'm creating Vellum fluid here, okay, just like that. And all of these are the parameters. The only 2 parameters that I'd like you to concentrate on or focus on are the phase and the viscosity parameters, okay, and they're different to the Vellum fluid 2, and I'll go to that shortly, okay. But highly viscous fluid for fluid 1, and the phase is 1. When the phase is different for different fluids, Vellum solver knows there to treat them separately, okay. That's why you have phase, okay. And then I created a color, and here I grouped them again, called outer fluid, okay. Originally I started with outer fluid and inner fluid, and then now it just went as left or right fluid or top and bottom fluid, basically. But anyway, so I'm just going to leave it as outer fluid, but grouped up as points, okay, because these are points. And if you go to the fluid 2 setup, all of these are pretty much the same as this one, okay, except that these are in the negative direction. So what am I doing with all that? Okay, so if I look at the first fluid here, okay, and template this second fluid instead of the main sphere, you can see that the second fluid is on the right hand side and the first fluid is on the left. Guess what? When I move the frames, it'll do exactly that. It'll just create the sphere in the opposite direction of the first sphere, okay, first clipped sphere, okay. And that way I get the whole sphere, but this time I'm using fluid 1 for 1/2 and fluid 2 for the other half, basically, okay. And everything is pretty much the same except for the fluid 2, which the phase is 2 and the viscosity is 100, much less viscous, okay. And I call this FL2 and constraint FL2. Okay, so those are the 4 sources. Okay, we created now. It's all done. So let's move on to the actual collider at the bottom. So the idea behind this, which I did not use for render, by the way, is that when the eggs fall down, I didn't want them to go too far away from the camera, okay? So I created a kind of a bund wall so that they stay inside of this bund wall, okay? So I deleted the top part and I thickened it, poly beveled it. I didn't have to, but anyway. And then I created normal. And I fed that into the Vellum solver for collision geometry, okay? And the solver itself is substeps of 8. That's the only thing that changed, except for, and the ground plane. Ground position is -2. However, if I go to the front view now, you can see the ground plane is actually clipping the bund wall. And that's because of the camera angle. As I mentioned before, I did not render the bund wall itself. It's just to protect these eggs from not going further away from the camera. Okay. So if I dive inside of the problem solver, as you can see, there are 4 sources or inputs. The first one is the vellum balloon, which I have used the activation formula here, or expression. And these are the same. Basically, I copied this activation copy parameter and I just pasted them here. So I just need to change it in one location. Okay. So if it is greater than the first frame and you are, the 12th frame, for example, your activation will be 1 and the emission will start to happen. Okay. So every 12th frame, there'll be a new egg created. Okay. That's all that is. I should just disable this for now and I'll run a few frames and I'll come back. Okay. I ran a few frames here now. Let me show it to you. So there you go. I think it looks really cool. So it drops and then you can clearly see the embryo and the liquids or fluids interacting with each other. And this is why I colored them blue and red, so I can see, which one is white, etc. So that's pretty good. But you do notice that some of the liquids or fluids coming out, spilling out of the bubble or the egg, and I didn't want that. We're going to deal with that shortly, okay? But anyway, so it's not a heavy sim. It's actually going very fast. So I like to keep things as simple as possible, okay? So I've got a 70-second one. Actually, I'm going to just enable this one and choose the 160th frame where you can see everything. So the first one, I'm just isolating the main balloon by selecting non-selected and using main balloon. And the second one is the outer fluid. That one, this is the points group, okay? And then the third one is the inner fluid, and the fourth one is the embryo itself, okay? So I've got them all isolated now. So let's move on to the outside. So render main balloon. It's simple stuff. Just bringing that balloon in and creating a material called RS main balloon. And then outer fluid, okay? In here, what am I doing? So I'm bringing in the outer fluid. I'm also bringing in the balloon, and I'm grouping whatever is inside. If the fluid is inside of the balloon, then I'm going to keep it. So I created a group called keep, point group. And then I'm deleting whichever is not keep. So you can see these 2 dots here. These 2 dots have disappeared, okay? And then I'm just using the regular flip fluid technique to create the fluid itself. So fluid compress and particle separation is looking at the source fluid 1 grain size, okay? And then using this particle fluid surface, okay? So these are the settings, and I did not put anything in here, no, just these. And assigned a material, outer fluid. That's basically it. And then the inner fluid is pretty much identical to that one. So if I get rid of that, you can see these blue dots here. They'll go away once I group them and delete them, okay? And for this one, it's identical to the previous setup for outer fluid, okay? For this one, the material is inner fluid. All right, good. And it's the embryo, no big deal. Just brought the embryo in and, assigned the embryo material. And then the render ground. So this is the actual grid, okay? And I created material for it too. So that's basically it. As far as the camera is concerned, it's a 1080p HD, 50 focal length. And I did use depth of field with a sampling of this. And its position is here. And that's about it. The dome light, it's a Venice sunset. It is available from polyhaven.com for free. I'll leave a link in the description. Check it out. The only important thing about this light here is this gamma value, okay? By default, it's 1. So I switched it to 1.4 to give it more colorful, saturated look, okay? And the intensity is only 0.5. by the way. And I rotated it 180 degrees. So let's move on to the material. Main balloon, a simple glass material, nothing else changed. I just used this drop down here, okay, that's all. And the outer fluid is again water, but I changed some of these weights and roughness, and what else? Roughness here as well for the refraction transmission. And I used this kind of color here, okay, which is this one, I think this one here, okay. And the inner fluid is pretty much identical, except the color is different and the absorption scale is 4. So all of these are its parameters, so you can just copy them, I guess. Let me just check the outer fluid's absorption. Oh, it's only 1, you see? So it's different. Embryo is going to be another, let me see here. Yeah, although it says preset is plastic, I kind of use translucency as well. So it's more like it's got a subsurface scattering feeling to it. You know, it's not real. Because if it was subsurface, then I'd have used here as well as down here and whatnot. But I didn't. I used just the refraction, etc. Just like I would use for a glass, for example. Okay. So these are the settings. If you want to just copy them. Next is the RS grid. RS grid is just basic glass. That's about it. Nothing else. You know, I think I might have dropped the weight to 0, but diffuse weight, but nothing else. No big deal. Everything is default. Output. So there's the render ROP itself. Render ROP, again, no big deal. I just made sure that I forced the render asterisk objects for render. And because if you notice here, all of these have a prefix called RNDR, and that's why. Okay. And I have a threshold of 0.02 because I didn't mind it having a little bit of noise. I was okay with it. It's usually 0.01. And denoising is enabled. And the motion blur, GI, global illumination. But this global is very important. So reflection, trace depths, reflection, refraction, and combined were changed because this has got a lot of refractive materials. Okay, therefore you need to test it out and play with it to see which one fits best. Because sometimes if you don't have enough numbers here, it'll appear black. Okay, I'll maybe show that to you. Okay, shortly. Okay, let me go ahead and click a render, and I'll come back. Okay, so as you can see here, it looks pretty good. And it's still rendering because it's progressive rendering right now. But I just want to change these things right now to show you, okay? So if I were to drop this, let me just take a screenshot of that. And if I drop this reflection to 0, you see how everything just changed completely. And refraction to 0 and combined to 0, that's it, that's what you get. So this was 8. You're still not getting anything because combined is still 0. So I'm just gonna push this up to 16. Okay, so now you got something, but they're just black, as I said before. So if I increase it to 8, it looks okay. The more number of eggs that are in line with the camera, in the camera's view, the more these numbers will be, okay. So I'm just gonna put this back to how it was originally. And this will increase your render time, by the way, just so that you know. Okay. I have also used the ASYS color space, which is, by the way, default, I think. So that's that. I think we are pretty much done here. Okay, so I hope this helped you and you learned something from it. If you did, please give me a like, share, comment, subscribe. I'd really appreciate it. And please have a look at my Gumroad page. I'd appreciate your support there too. Until next time, take care.